Okay, so now we'll do numbers 2 and 4 together. So first of all, if we know this is 27, this would also be 27, right? Because opposite sides are congruent. Next, if this is 15 here, then this would have to be 15 because the diagonal gets bisected. But since the total diagonals must be equal, these would also be 15 apiece. Right? So next thing that we could figure out is we can use Pythagorean theorem to figure out what BC is equal to. So we see that there's a right triangle here, and we have 27, and 15 plus 15 is 30, and x. So if we set it up, it would be c squared is a squared plus b squared. C squared would be the hypotenuse part, so 30 squared is x squared plus 27 squared. And so in the calculator, we'll do 30 squared and subtract that from 27 squared. Okay, so 30 squared subtract 27 squared. And don't forget, we want to square root the answer. So that gives us 13.07, so roughly 13 for x. So that's for BC, would be 13. Notice BE we already found to be 15. BD, the entire length of the diagonal, would be 30. And AC would also be 30. All right, next one is talking more about angles. So the first thing I would conclude is that this angle here would be 64 degrees by vertical angles, right? Then I could do 180 minus 64 to get the adjacent angles there. So this would be 116, okay? Now I remember that since these are going to have to be equal to each other, I can start by doing 180 subtract 116 to see what's left over, and that gives 64. And that 64 has to be divided into two equal parts. So they would each have to be 32 apiece, right? So that makes this add up to 180. Same thing would be true on this side, okay? And then lastly, I can look at this and realize that the whole thing is a 90-degree angle, and I could subtract 32 to find the inner portion. So the inner portion here would be 58, same thing here, and also here. The measure of angle XWY. So X to W to Y is 58. YXZ, so starting at Y, going to X, going to Z, that's 32. WVZ, W to V to Z is 116. XWZ, X to W to Z, that's 90 degrees. XZY, X to Z to Y, that's 58.